Welcome back to Calculus AB. Today's topics 5.8, sketching graphs of functions and their derivatives, and topics 5.9, connecting a function, its first derivative, and its second derivative. So we're going to start off, we're going to be looking at graphs today, so we're going to be connecting again between f prime, maybe f double prime as well. So you're given a graph of f prime of x, sketch a possible graph of f of x. So we're looking at f prime of x. So first we're going to start off by analyzing what f prime of x is doing. Right? So if you guys notice, we obviously can see it's just a flat horizontal line. So we can say that the value of f prime of x is always 2. And then, so what this is saying, right? What this is saying, remember, this is a constant value. So what this is saying is that the slope of the tangent line, so if you guys remember, that is still the slope of the tangent line. The slope of the tangent line to f of x is always 2. Is always 2. So that means it's always the same. It's a constant. It's never changing, right? So this is pretty much that this means that the graph of f of x must be aligned with a slope of 2. And now, for right now, we're going to say that so if we're going to make our language, so we know again something in y equals mx plus b form, right? So we can say that this is going to be y equals 2x. Now, the y-intercept right now is going to be irrelevant. So we can say the y-intercept for right now is irrelevant. And then, meaning it could be anything you guys want. So if you want to put it on 0 or something like that, as long as your line has a slope of 2, it's a perfectly valid answer. So I'm going to start this one at 1 right here. So I'm going to go 0, 1, and then up to 1 to the right. And then as long as you have 2 points, you can always only draw one straight line through those 2 points. So this is a valid answer. If you guys put it with this y-intercept of 0, it's perfectly fine as well. Okay. So now looking at part B. So looking at part B, we have f prime of x is pretty much just a straight line going up. Seems to have like a slope of 1, right? Up 1, 1 to the right, up 1, 1 to the right. So let's start off with the f prime of x analysis. So again, one of the things I want you guys to notice is here, remember that f prime of x, if it's below the x-axis, that means that it's negative. So that should tells us something about what's happening to f as well. So we're going to start off with that. We're going to say that the value of f prime of x is negative on negative infinity to 0, and it's positive from 0 to positive infinity. So again, what this is telling us, right, that there's a change in f when we're going from increasing to decreasing and decreasing to increasing, right? So here we're going to say that this means that, so this means that f of x that f of x changes from decreasing to increasing at x equals 0. And again, this would mean it has like a relative extreme at that point, right? So it has a relative minimum actually right there. If it's changing from decreasing to increasing, it has a relative minimum. So now Another thing that we want to point out here is also the value of f double prime of x. So remember, using the second derivative test, if I were to take the derivative of f of x here, if you notice, it would be just a constant's positive value, right? So I could say like f double prime of x would be just like positive 1, because that's the slope of this line. So if f double prime of x is greater than 0, that means that the graph is concave up, pretty much on the entire interval from negative infinity to positive infinity. So to conclude this, we're going to say that the value of f double prime of x is always positive so therefore f of x is always concave up. And now to make the graph for this, so again, we would have a minimum at 0. So put it right there. And it's decreasing from left to right. So we can have it's going to be pretty much just a parabola here. Let's say about right there. So it's decreasing and then it changes, right? And it's always concave up and it then starts to increase again. And we keep going up as well. So that is the possible graph for f of x. And again, here I could have different y-intercept. It really doesn't matter. Just wanted to start at 0 here, okay? But for sure, this would always be true. That changes from decreasing to increasing at x equals 0. So now looking at example C. So we have f prime of x, and that is downwards parabola, concave down. So we're going to say, first of all, if you guys notice again, let's start off with where is it at? Where is f prime of x? And here it's always below the x-axis. So we're going to start off with that. We're going to say the value of f prime of x is negative or 0 on the interval between negative infinity and positive infinity. So f prime of x is negative or 0 right there. That's the only part with 0 on the interval negative infinity to positive infinity. And then again, so this would be saying that the graph of f of x is always decreasing. And then for what we can say as well for f double prime of x. So f double prime of x, we can say the value of f double prime is positive, right? It's positive if I take the slope here. So from negative infinity to 0, it's positive. So that means that the graph should be concave up on that interval. And then it's decreasing where it reaches 0. It reaches 0, which is a possible point of inflection. And then it starts to decrease, so meaning the graph should be concave down on the following interval. So we're going to start off again by saying f double prime of x. So the value of f double prime of x is positive, right? Greater than 0 on the interval from negative infinity to 0. So again, the graph is concave up. Therefore, f of x is concave up on that interval. Negative infinity to 0. And then again, same thing, right? So the value of f double prime of x is negative on 0 to positive infinity. So we can see again that therefore f of x is concave down. So from there, so again, that means that at zero, it's going to change concavity. So we're going to be concave up from negative infinity to zero. So it would be decreasing, decreasing, right? It's always negative. And then it reaches zero, changes concavity, and then it starts to concave down on that interval from negative infinity to zero. So that would be the possible graph for f of x.